In this video, let's go ahead and try a definite integral application problem where we find the area between two curves. First things first, let's go ahead and just identify the area that we are taking a look at. And it looks like in this particular problem, we're going to be finding the area that's going to be under this curve, but above this straight line. So now that we know that we're going to be trying to find the area between these two lines, let's see if we can figure out where the upper bound and lower bound of this space is. Now notice this x value of pi over 6 and 5 pi over 6 because they're going to let us know where the lower bound of our shaded region is going to be, as well as the upper bound of that shaded region as well. So the reason that these two x values are important is that this will be the lower bound of our integral, and this will be the upper bound of our integral. Now we already know the equation of this curve over here that was given to us, right? The equation of this curve is going to be this y is equal to sine of x, but I guess the question is what is the equation of this horizontal line or this curve? If we can go out and find out the ordered pairs of these 2 points, then we can go ahead and use those 2 points to find the equation of that straight line. So since this point is on both of these curves, we can go ahead and use this pi over 6 in for our x value and find out the y value here if we plug it in. So if we go ahead and plug in that x value of pi over 6 into that sine function, that's going to equal 1/2 since sine of pi over 6 is equal to 1/2. So this point right over here is pi over 6 comma 1/2. What about this point over here where x is equal to 5 pi over 6? Well, if we plug in 5 pi over 6 into that sine function, sine of 5 pi over 6 is actually also equal to 1/2. So now we know that this point over here is pi over 6 comma 1/2, and this point over here is 5 pi over 6 comma 1/2. So at this point, we can see that the y values at both of these points are the same. They're both equal to 1/2. So this yellow line over here must be a horizontal line of y is equal to 1/2. This is what the equation of that second line or second curve is going to be, that horizontal line of y is equal to 1/2. Now at this point we know the lower bound and upper bound of our definite integral, but we need to identify what the upper function and lower function are that contain our curve. So we have two curves, but we're going to go ahead and identify that this curve here of y is equal to sine of x is going to be our upper curve, and this y is equal to 1/2 is going to be our lower curve, just because of where they are located containing the area of that shaded region. Alright, so if that's the case, let's go ahead and write our definite integral here. Now our lower bound is going to be this pi over 6. And our upper bound is going to be 5 pi over 6. Remember, when we are writing these integrals, we're going to go ahead and take our upper function here, which is going to be our sine of x. We're going to go ahead and subtract our lower function here, which is going to be our 1/2. So we have sine of x minus this 1/2, and that's going to be the upper curve minus the lower curve, and then we have, of course, this dx. This right here is the definite integral that represents the area of that shaded region. Alright, let's go ahead and see if we can evaluate this. Alright, first things first, if we go ahead and integrate this sine of x, that is actually going to be negative cosine of x, and that hopefully makes sense because if you take the derivative of negative cosine of x, you're going to get sine of x. Then when we go ahead and integrate this negative 1/2, that's just going to end up being negative 1/2 x. And again, if you just want to check this, if you take the derivative of negative 1/2 x, you're going to get that negative 1/2, so it works going backwards as well. Alright, so this is what we're going to get after we integrate. And now let's go ahead and evaluate it from pi over 6 to 5 pi over 6. Alright, so when we do this, we're going to go ahead and plug in this 5 pi over 6 in for x first. And here's what that's going to look like. And then we're going to go ahead and take our pi over 6 here, which is our lower bound, and then substitute it into our functions as well. Here's what that's going to look like. So first we put this 5 pi over 6 in for x in both of those locations, and then we took this pi over 6 and did the same thing, and we just took the difference of the two because we're doing that upper bound minus the lower bound. Alright, at this point, this is going to be just a little bit of review of trigonometry. Now, if we take cosine of 5 pi over 6, that is going to be negative root 3 over 2. And then if you take a negative of that, a negative root 3 over 2, or the opposite of root 3 over 2, is going to be a positive root 3 over 2. So looking at that first piece, we're going to get positive root 3 over 2. And then what's going to be next here, if we go ahead and then just multiply 1/2 times this 5 pi over 6, that's just going to be negative or minus 5 pi over 12. All right, so that's what we're going to get from this first grouping from over here. That's going to be from the upper bound. And let's go ahead and take a look at the lower bound now. Now for the lower bound, if we take cosine of this pi over 6, that is going to be root 3 over 2. But we have the opposite of that, so that's going to be negative root 3 over 2. And then finally we have this 1/2 times this pi over 6, so that's minus 1/2 times pi over 6, so that's going to be minus this pi over 12. All right, now if we go ahead and distribute this negative to here and to here, this first part is going to stay the same, and then we're going to get a plus root 3 over 2, and then it's going to be plus this pi over 12. All right, next let's just clean this up a little bit. So if we go ahead and simplify, we can go ahead and combine some like terms here. So if we combine this root 3 over 2 and we add another root 3 over 2, that's going to equal 2 root 3 over 2. But then if we have this 2 root 3 over 2, the 2's are going to cancel, so we're just going to have root 3 if we go ahead and add those two pieces together. And then if we go ahead and combine this negative 5 pi over 12, go ahead and add a positive 1 pi over 12, that's going to bring us to negative 4 pi over 12. But 4 over 12 is just a third, so it's going to be just minus this pi over 3. So by combining some like terms together, we got this root 3 that was from combining those radicals, and then if we combined those pi values or pi terms, we have this negative pi over 3. Alrighty, so taking a look at this, we know that area of that shaded region is going to be this root 3 minus pi over 3 square units. Alrighty, so that just about wraps up this practice problem where we practice using a definite integral to find the area between two curves. If you found the video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. Feel free to also share this video with a friend or classmate who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.